There is an object in the universe so massive that the word massive no longer means anything. We have a number for it. We have coordinates. We have observed it directly. And still, when physicists sit with what it actually is, the math starts to bend in ways it shouldn't. This is not a metaphor. Ton 618 is real. It is out there right now. And what it represents, what it quietly implies about the nature of space, time, and existence itself, is something most science communication refuses to sit with long enough to understand. Let's be precise about this. Ton 618 is a quasar. That's the official classification. A quasar, a quasi-stellar object, is what happens when a supermassive black hole at the center of a galaxy feeds so aggressively that the material spiraling into it releases more energy than the entire galaxy surrounding it. That sentence needs to land. An entire galaxy, hundreds of billions of stars, all of their light combined, outshined by a single feeding event at the center. Ton 618 is not just a quasar. It is one of the largest, most luminous, and most extreme objects ever confirmed to exist in the observable universe. And it breaks things. Not dramatically, not with an explosion or a shockwave you can point to. It breaks things quietly in the equations, in the models, in the assumptions we built our understanding of the cosmos on. Here's what that actually means. Ton 618 sits approximately 10.4 billion light-years away from Earth. That distance alone should give you pause. When the light we used to observe it began its journey toward us, Earth did not exist. The Sun did not exist. The solar system was billions of years away from forming. We are not looking at Ton 618 as it is now. We are looking at it as it was 10.4 billion years ago. What it has become since then, we cannot know. We cannot see it. That version of Ton 618 is beyond our reach, separated from us not just by distance, but by time itself. But here's the problem. What we can see is already impossible enough. The black hole at the center of Ton 618 has a confirmed mass of 66 billion solar masses, 66 billion times the mass of our Sun, compressed into a single gravitational object. Let that number sit for a moment. Our own galaxy, the Milky Way, has a supermassive black hole at its center, Sagittarius A. It is enormous by any human standard, over million solar masses. Ton 618 is 16,500 times more massive than that. If Sagittarius A is a mountain, Ton 618 is a planet. The Schwarzschild radius of a black hole, the boundary of the event horizon, the point of no return scales with mass. The more massive the black hole, the larger the event horizon. For Ton 618, the event horizon has a radius of approximately 1,300 astronomical units. 1 astronomical unit is the distance from the Earth to the Sun. The event horizon of Ton 618 spans 1,300 of those distances in every direction from its center. Our entire solar system, every planet, every moon, the full reach of the Sun's gravitational dominance ends at roughly 100 astronomical units. Ton 618's event horizon is 13 times wider than our entire solar system. You could place our solar system inside Ton 618's event horizon and it would disappear. Not metaphorically. Physically. It would fall in and never return. Let's be precise about this. The solar system. Everything humanity has ever known. Every planet we've visited or studied. Every probe we've launched. Every signal we've sent into the dark. All of it is swallowed. Gone. Contributing nothing to what comes out. Because nothing comes out. And then something happened, or rather, something was discovered that made this worse. In the 1970s, theoretical work by Donald Lynden Bell and others established a rough upper limit for how massive a black hole could realistically get through conventional feeding processes. The argument was elegant. As a black hole feeds, the radiation it produces pushes back against the infalling matter. At a certain mass, the radiation pressure should halt further growth. This is called the Eddington limit. Ton 618 should not exist under this framework. Not at 66 billion solar masses. Not at this size. The math says the radiation pressure from its own feeding should have slowed it, stopped it long before it reached this point. But here's the problem. It did reach this point. It is there. We have observed it. The universe built something our best models said couldn't be built. There are proposed solutions. Super Eddington accretion, the idea that under certain geometric conditions, matter can spiral in faster than the radiation can push it out. Chaotic feeding events. Early universe conditions we don't fully understand yet. But none of these solutions are clean. None of them are settled. They are patches on a model that keeps developing tears. Ton 618 exists at the edge of what our physics can explain, and it does not care. Here's what that actually means for what we think we know. Our models of black hole formation are built on observations of the local universe of galaxies close enough to study in detail, black holes small enough that our instruments can resolve their properties precisely. We build the rules from what we can see clearly. Ton 618 is not close. Ton 618 is at the edge of the observable universe in the early cosmos, in conditions that may have been fundamentally different from anything that exists today, and yet it followed rules, or it broke them. We're not entirely sure which. The early universe was denser, hotter. The geometry of matter distribution was different. Gas clouds were larger, more abundant, less disrupted. Black holes forming in those conditions may have had access to feeding rates that simply don't exist anymore. That can't exist anymore, because the universe has expanded and cooled and thinned out too much. Which means Ton 618 may be a relic, a survivor from an era of cosmic violence that has since ended. A thing that could form then but could never form now. The universe built it once, under conditions that no longer exist, and then moved on. But the strangeness does not end with formation. When you cross the event horizon of a black hole, you do not immediately die. This surprises most people. For a small black hole, a stellar mass, a few times the mass of the Sun, the tidal forces at the event horizon are catastrophic. The difference in gravitational pull between your head and your feet would be so severe it would tear you apart. Spaghettification. A real term, a real process. You would be stretched into a ribbon of atoms before you ever reach the singularity. For Ton 618, this is not what happens. The event horizon is so large, 1,300 astronomical units, that the tidal gradient at that boundary is actually gentle, survivable. A ship or a person crossing the event horizon of Ton 618 would feel nothing unusual in that moment. You would cross the point of no return without knowing you had crossed it. There would be no alarm, no physical sensation, no warning. The universe outside would still be visible, still be observable for a while. And then, as you fell inward, light from the outside universe would begin to distort, to concentrate into a shrinking circle ahead of you, and the walls of the future would close in. You would have time to understand what had happened, time to measure it, time to watch the entire future history of the outside universe compress and flash before you as you approach the singularity, though the experience of that compression would itself be lethal before it was complete. You would die informed. This is a strange kind of horror, not sudden, not loud, not violent at the threshold, just final. And then something happened that made physicists reconsider the threshold itself. In 2012, a paper by Ahmed Almheri, Donald Merrill, Joseph Polchinski, and James Sully proposed something now known as the firewall paradox. The math of quantum mechanics, specifically, the requirement that information is never destroyed, demands that the event horizon of a black hole be something other than smooth empty space. If information must be preserved, then the event horizon must be the site of something violent, a wall of high-energy radiation, a firewall. But general relativity says the opposite. It says the event horizon should be unremarkable, that an infalling observer should notice nothing. Both of these things cannot be true simultaneously, and yet both are demanded by their respective frameworks that have each been tested and confirmed to extraordinary precision in their own domains. Ton 618 is not just a massive object, it is a place where the two foundational theories of modern physics directly contradict each other, where quantum mechanics and general relativity arrive at the same location and produce incompatible predictions. We do not know what actually happens at the event horizon of a black hole. We have never observed it. We cannot observe it, and our best theories disagree. ton 6181300 wide, 66 billion solar masses, is the largest arena in the known universe for a question we cannot answer. There is a concept in cosmology called the observable universe, the sphere of space from which light has had enough time, since the Big Bang, to reach us. Beyond that sphere, things exist. The universe almost certainly continues. But we cannot see them, cannot reach them, cannot communicate with them. They are outside our causal horizon, separate universes of experience in a practical sense, even if not a physical one. Ton 618 sits near the edge of that sphere. It is almost at the boundary of what we can perceive, almost at the limit of our causal reach as observers. 10 billion years of travel time separate us from its light, and from something that far away, we have extracted a measurement, a mass, a size, a luminosity so extreme it outshines entire galaxies. There is something quietly disorienting about this. We are here, on a small planet, orbiting an ordinary star, in an unremarkable region of a mid-sized galaxy, and we have built instruments sensitive enough to detect a single object, 10.4 billion light-years away, and determine that it masses 66 billion suns. The universe permitted this. A species, on a rock, looking at the edge of everything, and finding something there that breaks the rules. What ton 618 is, at its core, is a limit on size, a limit on energy, a limit on what the laws of physics, as we currently write them, can accommodate. It is a reminder that our models are maps, and maps are not the territory. We drew the map carefully. We tested it everywhere we could reach, and then, at the far edge of the observable cosmos, we found something the map didn't predict or couldn't predict, and we had to stare at it and admit that the map is incomplete. Every equation we have describing black holes, accretion, radiation pressure, event horizon physics, every one of them produces a result. When you run it on ton 618, the results just don't all agree with each other, or with what we observe, or with what seems possible. Something is missing. Some piece of the framework. Some deeper rule beneath the rules we know. Ton 618 is not a crisis. It is a clue. A 66 billion solar mass clue. Sitting at the edge of the observable universe. 10.4 billion years in the past. Waiting for the physics we haven't written yet. The universe built something we can't explain. And it has been waiting, quietly, for us to catch up. We haven't yet.